Hey again. So yeah, it's time for a new challenge. Hash maps and arrays, yeah, we've done them before already, and they are considered pretty easy. So what we're going to be doing in this section is we're going to give ourselves a challenge, and we're going to be coming up with solutions that have some sort of special property. Either the solution will be a one-liner, or it'll have some sort of reduced time or space complexity. In this first hash map and array problem, we're going to be solving it using a one-liner. It looks cool, but otherwise it's not very efficient. So let's not rely on this. Let's more just be impressed that we can write it in one line. And anyway, what we have is a list of numbers, and we would like to return the top k numbers in the list. Now you can imagine all sorts of practical applications in like data analysis, where, for example, we might want the top 3 results in a survey. So what should we do here? What we need to do is we need to use some special device called a counter, which is a subclass of a Python dictionary that allows us to count hashable objects, like lists. So what we're going to do is we're going to transform the list into a counter, which is really nothing more than a frequency map, mapping the number with its occurrences. Then we will sort the counter by frequency in reverse, and we will select the top k elements in that sorting. The top 2 elements are 1 and 2. We know what to do now, and we can write this quickly using a one-liner. Really, this is more to show off more than anything, but let's go ahead and look. So we know that we're going to be sorting our answer, and we know that we will be sorting a counter, and we're going to be sorting the counter hash map of our nums, specifically the keys of the hash map. We're going to take as our key for the sort a lambda function. And as you know, a lambda function is a kind of filter. So what are we going to be filtering? We're filtering the values that our keys from our counter hash map are producing. We're then going to reverse the sort. And finally, we're going to take the first k values from this reversal, ensuring that we're going to have the top k values based on the list frequency. Since we sorted our list, the time complexity will be O of n log n. We are also using a hash map to store our counter, which has size n, and so the space complexity will be O of n. Yeah, that was pretty short. So why such a short video? Well, in addition to only needing a one-liner, we're going to discover that this is not the most optimal solution. We can actually reduce the time complexity down to O of n, and we're going to do so in the next video. I'll see you then.